Hey everyone, this is a BC calculus or AB calculus. My apologies. This is an AB or BC calculus concept, and I built these in CAD to try and help people understand things. It's very challenging, conceptual, and no matter how good you are at drawing them, unless you're Sal Khan, apparently, they're very difficult to draw. So we're told, hey, here's a shape. In this case, it's a semicircle. And actually, I want to turn that on its head a little bit. And you have a semicircle, and you have these shapes coming up out of it. And those shapes are right triangles, or those shapes are semicircles, or those shapes are squares. So again, you look at the top, and you see nothing. You just see the semicircles. And I built this way so I could 3D print it to help people understand. What is the area of those squares? Then you integrate it along the function. If you notice, the base is constantly changing, which means the height is constantly changing. But I'm just trying to help you visualize. This is the XY plane. X across, Y up and down. And what's coming up out of the XYZ plane? Squares, things like that. So hopefully this helps you visualize. Here's semicircles. They could also be full circles if they popped out the bottom, but they don't. They're just semicircles. So you take this Y value, which is a function of X, and you cut it in half, and you go pi r squared, and that's a hassle. I'll let your math teacher handle that, but just for visualization purposes. Now, be careful reading. I just screwed this up earlier tonight in a very impressive way. What kind of triangles we got here? These are right triangles. So if we look at them from the side, they're isosceles right triangles. They have the same base as the height. So you can just go 1/2 base times height, and the base is f of x, 1/2 f of x times f of x, so on and so on. You could take them and make them equilateral triangles. You could take them and put the hypotenuse face down. This is a 45, 45, 90 right triangle, isosceles right triangle with one of the legs along the base. So you got to be very careful and read them. This is something else I wanted to show you. Here's a shape in the XYZ plane. It's basically sine, and it's sine of x plus, I don't know, it looks like 2. And it says, hey, take that shape and wrap it around the x-axis. And a lot of people go, I can't visualize that. So the nice thing here is we can actually say, take that shape and wrap it around that axis all the way around, and that's what we get. So it looks like a vase. It's pretty cool. But what's that cross section on the end? It's a circle. So you got a circle. Hey, that's pi r squared. The r is constantly changing, so you write in a function, and off you go. Now I want to undo that, and I want to try something else. I'm going to go back into the sketch, and I'm going to draw a horizontal line down here, and we'll see if this works. I don't know why it's grabbing all that stuff up there. Alright, finish sketch. Now, this is called the washer problem. Hey, wrap that around something further down, maybe the line y equals -2. So revolve that shape, and what axis? This one. And what happens? You get a hole in the middle. Alright, so they call this a washer problem because you have to go pi r squared, the outer circle, minus pi r squared, the inner circle. And it's a tricky little problem. So it's a pretty useless vase. The water will all run out the bottom, but it looks cool. It's a cannon. Haha, that's what. Okay, I'm losing it. Anyway, hopefully that helps you do some visualization. Best of luck.